Hello everyone and welcome to Meanwell CAN bus training. In this short presentation, we would like to introduce you to an easier way how we can create a CAN bus commands for BIC 2200. With this new tool, you will not have to look at user manual for command code, check scaling factor when conversing data from decimal to hexadecimal, or remember to reverse high and low bytes before command will be sent. But before we start, the CAN bus command structure needs to be explained briefly. After that, our tool will be introduced and some examples will be demonstrated. As we might know, the CAN bus command is divided into 4 sections. 1. CAN ID, which decides if controller talks to the power supply or opposite. 2. DLC, which describes how long the data sent or received from power supply is. 3. Command code, which describes what kind of information we want to read or write. 4. Data, which are feedback from power supply or which we want to save in its memory. The BIC 2200 CAN bus tool was created with the idea to help user understanding the CAN protocol, which at first might look complicated. Its construction, the way how read and write communication between CAN controller and the device is done, might seem to be rather complex. But with our tool, we hope to bring the CAN protocol closer to the end user, especially to the ones who needs it only occasionally. It will be explained how just in few simple steps we can read or write specific command in quite easy way. Now let's move to the real examples. Let's say we want to change output current to 25 amperes. If we want to do it without our tool, we will need to go through BIC installation manual, check all the necessary codes for CAN ID, DLC, and IOutset command, translate data from decimal to hex. Not to forget that converted data still must be reversed. When using our tool, we just need to select proper PSU ID number, command name from drop-down list, and write down decimal value that must be sent to PSU. Tool will give already whole command. A copy button can be used to copy to clipboard command code and data that can be further passed into CAN controller software. Like the right example, when we want to read data, we need to follow up the installation manual in details to create proper read command and further translate hex data to decimal, binary, or text type what can be challenging. With our tool, we can get proper read command quite fast, and feedback from PSU will be translated for us immediately. In this video, it will be presented how to establish CAN bus communication between CAN controller and CAN software, read V-out setting, how to adjust it and confirm the change. As for the software part, we will use free tool called USB CAN tool. As for controller, we will use Canalist 2.
In the beginning, we need to make sure our CAN communication is established properly. First, we go to the operation option and we click Start button. Next, we select our CAN controller and proper baud rate of 250 kHz. As data format, we choose Extended and we keep the type option in default settings. After the basic connection settings are finished, we can go to next step. First, we need to choose proper CAN ID information. The message ID will be always constant. We just need to choose proper PSU ID and command name from drop-down lists. Tool will generate immediately the full read command, from which we can get the CAN ID data. We just need to simply copy to it the software. Creating CAN ID is one-time job. Later, only read and write command names and their data will change. After CAN ID is established, we can generate specific data code, which we will be sent to BIC 2200. Again, we go back to our tool and copy already created hex code. For this purpose, we can use Copy button. Next, we just simply paste it into the software and click Send. As we can see, the power supply gave us feedback about the current settings. Now, we just simply need to write it in specific cell to get feedback in readable format. Now, let's try to change V-out settings to some other value. For this purpose, we can use Write section. Here, we just need to select correct PSU ID, command name, and write in the value to which want to change the PSU settings. Tool will give us command, which we just need to copy to the control software by using Copy button. Again, as we can see, creating correcting data is quite straightforward. After the generated command is copied, we just click Send button, because PSU will not feedback with saved data. To confirm that new settings were accepted, we need to delete the data value 8813 and hit Send. PSU should feedback us with the value that we sent in previous step. In the end, we can always confirm these data in our read section.
To summarize this training, I just hope that presented tool can be useful for all users who don't really deal with CAN bus very often and will make all reading or writing process smoother. Also, please remember that this is only a support tool, created not to replace the real CAN software, but to make our life easier when we don't use this specific communication method daily. Thank you for your time. If you have any comments or questions about today's presentation, you are welcome to contact us for any further support.